Hi everyone, welcome back to Learning with Maria. Today I'll be sharing something with you that you might have heard before, but I recently gained a more comprehensive understanding during my master's degree about this. So, as we all know, there is no one size fits all solution to every case, and the same applies to handling missing data. It's worth exploring the best method for dealing with such cases rather than simply deleting the rows with missing values or imputing them with mean or median values, especially in numerical cases. So to kick things off, let me provide a little bit understanding about missing data. I'm gonna share with you all the link that I share here in the post. So first we need to know about missing data. So throughout this post or medium article, actually the objective of this post is to provide a basic process for identifying and treating the missing data. And the author used Titanic dataset and summarized the steps into three. First, do some exploratory data analysis, where the idea of doing this is actually to understand where actually the missing data exists, and if there's some case of like, is there any pattern between the missing data in this variable, um, and then we see like the connection or the possible correlation with the other variable as well. But after we understand that our missing data for this Titanic data set, for example, is on the class where we have three classes there, class 1, 2, and 3 of passengers, but we have missing values there where we don't know on those passengers which class they are belong to. So the secondly, after we do the EDA, is to identify the types of missingness of the data. And here we are going to learn more about what is actually missingness mechanism that we have there. So there are three categories of missing mechanism. First is MCAR, or missing completely at random, and then second is missing at random, or MAR, and third is missing not at random. And the author also has tried to summarize uh, how to deal with such cases. So for example, when we have our missing values or missing data in MCAR category, the treatment is advised to be to delete it, and MAR to impute it, or MNAR to improve or sensitize it. But first, we need to understand first about each of the category. So MCAR, or missing completely at random, the missing values have no correlation with other values in the data set observed or missing. So for example, if there's like a questionnaire or like a survey where we need to know aside of whether or not the students attend to class or not, we need to also know the reason why the student do not attend or attend the class. And it turns out that there's like missing values or missing data on the reason. So for example, if a few students in a class happen to be absent one day for their own individual reasons, that's MCAR, because there's no correlation with other values in the data set observed or missing, because it's their own reason or their own individual reason. Meanwhile, missing at random, there's an underlying reason for missingness that can't be directly observed. So, for example, with the same example, it is flu season and few students are out sick. We don't have such variable in our data set that the period where some of our students is not attending class, if the period is actually the period of flu season, for example. But if we further understand that, further like getting data from the outside, if we have such cases, then we can get a better understanding that probably the students do not attend because it is like a flu season, something like that. Meanwhile, missing not at random, there is a relationship between missingness and its values. So the question would be whether students most likely perform poorly on the tasks are missing. And a great way to explore missing data is actually to visualize it and the author tried to further explore about one of the solution on doing this visualization using missing no. But I'm not going to share more about that, but further about the next step, which is treating the missing data. So there are some possible ways to treat missing data, including first deleting. For deletion, the process is actually it's very simple. We just need to delete and that's all. But the cons is we need to assume this big assumption where the data is MCR or missing completely at random, where although we delete the observation, it won't impact badly in our data, and introduce bias if not MCAR. So the option of doing deletion includes listwise deletion or complete case analysis, where we remove all data for a record that has one or more missing values, and then pairwise deletion or available case analysis, where we only interest on the specific variables that we want, and then only delete observation where that specific variables has missing value in it, but we don't need to delete all other rows where it is missing in the other variables. And column deletion is performed when the majority of data for the feature are missing values. So for example, on variable gender, or no, for example, on variable salary, like 60% of the salary data is missing, um, then probably on such cases, on that context, for example, it's worth to consider just delete the column overall rather than to predict it. And the next, after we delete it, the other option uh, are the other option is single imputation, where it includes mean or median imputation, where mean is better to use when we know that our data more likely like a normal distribution, where median imputation is more like when we deal with data that distribute a little bit skewed, for example, where the pros is actually it is relatively simple, but cons it's reduced the variance because we only care with the summarization or the central tendency rather than the variance. And hot tag method, and the next is single regression imputation, where observation with complete features are used to predict the values in the missing data, and stochastic regression. And the other option are multiple imputation, where it is unbiased, but the cons is it is a little bit more complex when we compare with the other two options we discussed just now. So one of the way is multivariate imputation by chain equation or MICE. So it involves filling in the missing values multiple times, creating multiple complete data sets. And the next option is to do sensitivity analysis, which is to show the range of uncertainty due to missing data. So when your data is MNAR, this is about the best solution. Otherwise, we need to collect better data. So let's learn further about the package that we have here, which is MICE. So MICE, as I mentioned before, stands for multivariate imputation by chain equation. So it's actually like a statistical method for handling missing data by imputing incomplete values through a series of regression models taking into account the relationship between variables. So here we have like a lot of arguments, which includes m, or the number of multiple imputation with default m equal to 5, and also we have the method that can be either a single string, or we can also specify another like factor of string with length blocks, specifying the imputation method to be used for each of the column in data. But if we specify only single string, it means we specify the same method for all variable that has missing data. We also have ignore here, where for example, if we have five variable A, B, C, D, E, and we have an idea that E won't be helpful or won't be useful on describing the other first variables, which is A, B, C, D, so that we are on purpose ignoring variable E, then we can specify it here. And then we have other arguments also including default method here, where we can say if we want to specify the default method to be true, and max it, or like the number of iteration with default is 5. So actually the package contains function to inspect the missing data pattern and then impute the missing data m times, resulting in m complete data sets, and then diagnose and analyze and also to pull the results. So how it works is something like this. So for example, we have three variables here, which are age, income, and gender, where each of the variables also have like missing data there. So first, by using only single iteration, what mice does is doing mean imputation for all of these missing values, where for example for age it would be 25.5 for this specific row, and income would be this, and gender would be this one. There's also like when we deal with categorical value, then we need to get a mode rather than the mean, for example. And then after that, for example, first we want to predict age, then we need to return the value of age into missing value again, but leave the remaining value that we impute before as is. So then we can use the data that we have, the complete data that we have on income and gender, to model age using Bayesian linear regression in this context. And then after that, using complete case analysis, we can get um, the predicted value using linear regression prediction for age on the specific row where income equal to 13.3, 13.5 K, and gender is male. And we get it is the age is 35.3, or say it is 35. And then after that, we get the full or complete data for age, but then we also have another complete data for income, budget, and gender, but it is still using mean imputation there. So that we need to continue doing the imputation. Now we move to income, where we return back the income missing data into null again, and then we use the complete data of age and gender to predict the income. So we predict it, and then we predict it using linear regression, and then using age and gender to model income, so that we got income predicted value, which is 13K something for age 33 and gender female. And the same for gender for that, and also as a result, we get this full complete imputed data for the single iteration for this age, income, and gender. So instead of having the same imputed values for missing values within the same column when using mean imputation, for example in here where we have sleep, span, guest, and for example in the span variable with mean imputation, we have the repeated same value for um, the missing values like 19.9 for all of them. Instead of having that, mice will generate a unique value based on the predicted values from the model and the variable value on the respective row where the data is missing. So why it is powerful is it is considering the relationship and dependencies between multiple variables simultaneously, which can capture more complex patterns in the data compared to passive imputation methods that handle variables independently. And also it provides flexibility in choosing imputation models for each variable individually. As we have here, actually, there's also a lot of possible way to do the imputation, like using predicted mean matching, or we can also using logistic regression, and there's a lot of other things here where we can specify as we wish. And it utilizes chain equation where it allows imputed values to be updated iteratively based on the imputed values of other variables that we mentioned just now and here, leading to more accurate representation of the underlying data structure. There's also like one article where it tried to experiment with some method, including predictive mean matching up until multiple linear regression with bootstrap imputation inside mice. But I think it's cool to conduct simulation to further understand how, like for example, the RMSE or root mean square error is smaller when using mice compared to single imputation method, just like what we have here. So we'll discuss about that in the next post, and let me know if this is insightful for you. Thank you.